Hi everyone, welcome to Fun Coding. So let's start our data structures, and today's topic is BST searching. Okay, so this is the continuation of BST. Okay, so till now we have done insertion and deletion in BST, and now let's see searching in BST. Okay, so let's start. So if I have a question, let's search 10. I have a binary search tree here, and I have a question that search 10. So let's see how to do. First of all, you should know what is a node or a root of a tree. So root is this one, the starting one. Okay, from where it forms two sub trees, which is left subtree and the right subtree. Okay, so this is a root node. Now this left subtree, okay, so the root node of left subtree will be 6. This is a right subtree, and root node of right subtree is 19. Okay, so this goes in continuation, so let me explain you. Now in this subtree there are further subtrees. Okay, so if this is a root node, 6 is a root node, then its left subtree will be this and its right subtree will be this. Okay, so if 19 is a root node of right subtree, so 19's left subtree will be this one, only 17, and its right subtree will be 43 and 49. Okay, so let's start searching. So you have done the basics, what's a root node, and now see, I have a question that search 10. So okay, so firstly I have to see the root node of a tree. Okay, so here it is 11, so I will compare. So if 10 is equal to root node, okay, 10 is not equal to root node, 10 is greater than or 10 is less than. So if 10 is greater than 11, it's not true, so we will go to next condition, that is 10 is less than 11, so it is true. So in BST, if the number is less than root node, so it will be present in left subtree. If that element is greater than root node, then it will be in right subtree. Okay, so here 10 is less than 11, 10 is less than root node, so we will shift to what, left subtree. So firstly I have to see that if my 10 is equal to 11 or not. So it is not equal to 11, so I have to check if it is greater than or less than. It is less than 11, so I will check left subtree. Okay, so now next, now I have to check left subtree's root node. So the root node of left subtree is 6, so I have to check if 10 is equal to 6. 10 is not equal to 6, then I will shift to next condition, if 10 is greater than 6. So it is true. So if an element is greater than root node, then I have to see right subtree. So here right subtree is this one. So if 6 is a root node, then the right subtree will be this one. Okay, so now I will shift to right subtree. Okay, so firstly I have to left subtree, I have shift to left subtree, and then now after comparison I move to right subtree. Okay, so now right subtree's root node is 8. Okay, so this is a, now this is a tree, and this 8 is a root node, this 8. Okay, now what I will do, I will do the same process. I will check if 10 is equal to 8, it is not equal to 8, so I have to check another condition, if 10 is greater than 8, so it will be true. So if it is true, now 10 is greater than root node, so I will check right subtree. Okay, so right subtree of 8 is this. 8 has no left subtree, so don't get confused that every node will have left and right subtree. Okay, So right subtree will be this one. So subtree is left with only one element. So now we will continue same process. Okay, now I will move to right subtree. Then now I will check first condition if element is equal to root node. So 10 is equal to 10. So I have found the element. Okay, so let me give you an example that here I have 3, here I have 4, here I have 1. So now I said that search 5. Okay, I have given you a question that search 5. So firstly I will compare if 5 is equal to 3. If 5 is equal to root node, so it is false. Then I will check next condition if 5 is less than 3. 5 is not less than 3. Then I will check another condition if 5 is greater than 3. So 5 is greater than 3. This is the right condition. So I will move to right subtree. This is the correct condition. The condition becomes true. Now if element is greater than root node, then I have to check right subtree. Okay, so now I will shift to right subtree. Right subtree have left only one element, is left with one element. So I have to check if 5 is equal to 4. Now 5 is not equal to 4. So now I will check if 5 is greater than 4. So it is true, 5 is greater than 4. So I will check right subtree. Now right subtree of 4 has no element. Okay, so now see, right subtree has null and left also have null. Okay, so if element does not have right or left, then it will contain null. Okay, so it does not have any right or left subtree, so this means element is not present in the tree. Now next question is, what is the complexity of the program in searching, okay, in BST? So so I have searched 10. So it now the complexity will be log base to n. So how? I have a tree. This is the average case complexity. Okay, so after comparison I divide the tree into half. So if the element is present only here, then I have to not to check any condition. Okay, else I have to check if it is a right subtree or left subtree. So the tree is divided into half. Now I will compare with this, and then again the subtree will be divided into half. So as the tree is divided into half, so it becomes log base to n complexity. Now what is the worst case complexity? So let's see. Have a tree where elements are present like this, only one sided. Okay, so I have to compare every element. Now see, I have a question that search, 1 minute, search, oh I have here it should be 7. Okay, search 8. Okay, now I will compare 8 with this. 8 is greater than 5, so right subtree. Now this is a root node, so 8 is greater than 6, now right subtree. 8 is greater than 7, again right subtree. There is no element present, so I have compared every element, so complexity becomes n. Okay, but we have normally log base to n. Okay, so this average case complexity. Now this is the worst case complexity. Now to remove this, we use another type of tree which is BST only, but a small modification, which is AVL tree. And we will do in next video sessions. Okay, so till then, goodbye and happy learning. Okay, thank you.